Inverses of functions. Write the inverse algebraically. Note any necessary domain restrictions. Then sketch both the function and its inverse on the same coordinate plane. So first of all, inverse means to switch the x and the y. So we can write this as y equals square root of x plus 2. Switching the x and the y means the x goes for the y and the y goes for the x. Then we solve for y. So I need to subtract 2. X minus 2 equals square root of y. And then I need to square both sides. So x minus 2 quantity squared equals y. It's better written with the y first. In fact, we should use inverse notation. H inverse, h to the negative 1 of x equals x minus 2 quantity squared. So that's part of our answer. But remember, we have to look for domain restrictions. What does that mean? Well, let's go to the graph. If we use our x and y axis here, and we graph our original graph of h of x. This is a square root function, and it's shifted up 2 units. So up 2 units, and the square root of 1 is 1. The square root of 1, 2, 3, 4 is 2. There's a nice quick sketch of our square root function. If I were to sketch the function that we are calling the inverse, this guy right here, this is a quadratic, therefore the graph is a parabola, shifted to the right 2 units. So 2 units to the right, and then because it's a parabola, not only does it go this way, over 1 up 1, over 2 up 4, but it also goes this way, left 1 up 1, like this. Now remember, graphically, the inverse functions are supposed to reflect over the line y equals x. However, that new parabola is not a reflection of that square root function. So let's take it back a minute. If I didn't sketch the left side, and now we look at the mirror line, and I'll just do it dashed so it's easier to tell. Okay, so here's our y equals x, our mirror line. It does show a reflection, so why did I have to get rid of half of it? Well, remember that we're switching the x and the y's, and domain are all the x values. So I'm trying to figure out what are the restrictions on these x values, the domain. So if I want the domain restrictions for the inverse, that means I need to consider the range, the y, the range restrictions on the original function. Well, knowing that this was shifted up 2 units and looking at the graph, I can see that it starts at the y value 2 and it keeps going up from there. Therefore, the y values are everything greater than or equal to 2. Switch the x and the y, and now I get the domain as all the x values greater than or equal to 2. So that's my domain restriction for the inverse function. We've sketched both on the coordinate plane so that we can see that this is in fact a reflection over the line y equals x.